Okay. So my name's Rob Walpole. I work for a company called DevX Limited, and we're currently providing consultancy services to the National Archives. Basically, the project we're working on is developing a new digital archive. So first of all, a bit of a disclaimer. Anything I say is not the opinion of the National Archives, it's my own opinion. And anything I say that we might do at the archives, we may not do. So just to give you a little bit of background about myself, I've been working with XML technologies since about 2005, so doing XQuery and XSLT and things like that. More recently, I've moved towards semantic web, and it was interesting to hear Philip talking about the overlap between semantic web and XML. I'm not going to pretend that I've got any particular answers to these issues, but certainly we do deal with both semantic web and a great deal of XML. So I guess we found our own way of working with this, which I'll come on to. So just to give you a bit of background first of all, the National Archives is the UK's government archive. We have over 11 million historical government and public documents, things from the Doomsday Book, right through to, more recently, the agreement for referendum independence for Scotland. One thing the archives don't have are births, deaths and marriage certificates. That tends to be a bit of a misconception. These are held by the General Register Office. So most of the documents that the archives have at the moment are on paper, or parchment, in this case. But soon this is going to be overtaken by an enormous amount of digital documents, particularly as government departments tend to hang on to things for a little while, so we're lagging a few years behind. So the big data tsunami, if you like, is going to hit the archives in the near future. So that includes things like standard office documents, emails, images, DVDs, and unusual things like virtual reality models. You name it, we get it there. And there's lots of challenges around digital preservation, such as format recognition, preserving software, finding things that are becoming compatible, media degrades. But the archives, well actually this is the BBC Doomsday project, which caused enormous problems when they tried to, you can see this huge laser disc. You just know they're going to have problems with that. They managed to get around it in the end, but it did flag up a lot of issues. The National Archives have really been at the forefront of developing solutions to digital preservation issues. They have Pronom, which is a file format registry, Droid, which is a file format identification tool. You give it a file, it'll tell you what kind of a file it is. There's also been a number of developments alongside the National Archives. So we've had, in conjunction with TSO, we've had legislation.gov.uk. We've also been involved with the UK Government Web Archive, which uses the OWL in triple store. It's one of the largest triple stores in the UK government, certainly. And also been involved with the London Gazette, again in conjunction with TSO. So as far as digital archiving goes, in 2006 TNA developed a digital repository system which provided terabyte scale storage, but it didn't provide the extensibility that was needed. So in 2012 they started to develop DRI, the Digital Records Infrastructure, on the foundations really of DRS, using some of the same underlying systems developed further, but also taking the storage capacity to the petabyte scale and beyond. So we started off, that's actually, got that wrong there, that's it. They should actually say 80,000, there's only about 80,000 digitised home guard records were used as part of a trial project, just as a proof of concept. So that was documents that had been held by the MOD. They were scanned and then loaded into a mini version of DRI. That was successful, so the project's continued, and there's lots more data sets now waiting to go into the archive, including the Olympic Games Organising Committee documents, including many, many hours of DVD footage, the Leveson inquiry again featuring DVD footage, and much more. And basically this storage capacity is provided by a massive tape storage using a robot tape library. This isn't the actual tape library, but it's a very similar system with this robot runs up and down the middle, pulls out the tapes as required. So there is this thing called the DRI catalogue, which is what I've been involved in developing. And it really, the DRI catalogue is just an inventory of the things in the archive, in the digital archive. And it's distinct from the TNA catalogue, which is a catalogue which covers both digital and paper documents. And access to the TNA catalogue is provided to the public via Discovery, which is the website you see here. And you can just search in there. So in the archive itself, we actually have a huge amount of XML metadata. So every item that is stored in the archive, every document has an XML document that accompanies it that gives you information about that document. So that'll be things like who the record came from, what it's about, what the archiving process was. If it was a paper document, it might have some transcription with it, and the archivists themselves tend to add information they consider to be important as well. But apart from just being an inventory, the DRI catalogue has to provide some other fundamental functions, such as monitoring or maintaining closure information, because not all information in the archive is actually publicly accessible. A lot of it is closed. Not a lot of it, a small amount of it is closed. But it also becomes open after a period of time. So the inventory has to keep a monitor of the dates when records are due for opening. And once a record is opened, it gets exported to Discovery, to the public interface. So it also needs to maintain status about exports. I'll just skip over that slide. Actually, I've just realised. Okay, never mind. So the So initially, when the DRI catalogue was developed, it was held in a relational database. But there were some issues with this because closure can be very fine-grained. Basically, before we exported anything to Discovery, we needed to establish its closure status. And closure, you can have an individual record about, in the case of the Home Guard records, you can have a record about one person. So we might be happy to provide the metadata to Discovery so people can see that there is a record for this person. But we may not be able to release their service records, and we may not be able to release their medical records either. And there can be different closure on those two things. So you can have closure of, say, from somebody's service record, it would normally be closed until that person is deceased. In the case of a medical record, that's normally closed for at least 100 years after the record is initially created. So basically we had to find a way of getting this data out of the database. When we started using a relational database, it was taking hours to run the queries to find out which records could be released and which ones couldn't, because of this fine-grained nature of the closure. So we did some modelling as to which was the best way to do this. We fundamentally took three approaches. We used a relational model, so we had a look at improving and optimizing the SQL queries that we had already. We also tried using a graph model, so actually extracting the data from the database as RDF, and running Sparkle queries over it. And also we tried, or planned to try at least a hierarchical model, so that was using an XML database and running XQuery over it. And the result of that was that we were able to reduce the query time on using the relational model from hours to minutes, so that was a good result. However, the graph approach actually reduced the query time for establishing closure to seconds, so that was a very good result. And the hierarchical approach was actually abandoned, and the reasons that we abandoned it was because basically we found a solution with the graph approach The graph approach, when people started to think about it within the archives, they realised that it gave them other possibilities in terms of allowing, potentially in the future, things like linked data to be easily developed from that. But also, obviously, it's a project with limited funds and deadlines, so really the fact that we found a good solution obliged us to move on. So it's not to say that had we been able to do an XML approach that we would have got a good result, but we simply don't know. So really what we had to do is fundamentally question the nature of the information in the archives. And really what we discovered is because we don't really know what's going to go into the archives, it's just going to be government documents. They could be about all kinds of different things. It's going to fundamentally be about people, organisations, their relationships, their activities. They're very complex things. They're not things that can easily be modelled in tables or even in hierarchies. They're really multifaceted, they're polyhierarchical, and a graph provides a good solution to that. So during the trial we used a number of technologies. We used D2RQ for extracting data from the relational database, so that takes the data out of the database as triples. We used the Apache Jenner framework, including TDD, which is the actual triple store, and Fuzeki, which provides HTTP access to that. We used the Turtle format of RDF as opposed to RDF XML or any other format. That seems to be the preferred option at the moment because it is a very terse triple format. And we use Sparkle 1.1 query language for querying and updating the records. The reason we chose the Jenner framework was because it had an excellent Java API, which was important because most of the developers working on the project were Java developers, and because the underlying system that the archive relies on, which is to sell SDB, is a Java application, so it was just easier to use a Java API. And also because it's open source, and that's important because the UK government, they've recently produced the Government Services Design Manual, and that states that where there's no significant cost difference, that open source will be selected on the basis of its inherent flexibility. So obviously D2RQ and Apache Jenner both met that criteria. And also to use open standards, so again Sparkle and RDF are both open standards, so that was a natural choice. So this was the architecture that we came up with for the catalogue. So basically we have the safety deposit box, which is a Sicella product, which is the underlying archive software, if you like. And what we did is develop this thing called DRI Catalogue Services API, which is a very simple API. The reason for developing that was because it was perceived that there was a certain amount of risk to TNA in jumping to this triple store approach. It was such a fundamentally different approach that this enabled us to shield the business, if you like, from that approach. So we had this API that provided just a very simple service, and that API could then communicate with triple store, or if that didn't work for any reason, a relational database. It didn't really matter. So the W3C basically recommended reusing vocabularies wherever possible, but we needed to be able to talk about very specific things to do with DRI and the catalogue. So we found it was necessary to create some of our own terms. So we created a very simple vocabulary for DRI to do with things like closure and export. And to do that, we just extended the RDF schema language. So what we have here is an example. Sorry about the faintness of this one, but we have using a National Archives identifying URI really. We're declaring this thing called an export, which is a type of RDF class, RDFS class, and this thing called an export, which is a type of property. So with any triples, you have a subject. So in this case, an export could be a subject. You have some properties describing that subject. So in this case, we have an export member, for example, and the thing on the other end of that, the object, is, it can be a literal value, so it can be a string value, or it can be another class, it could be another something else. In this case it would be a class. So here we have an example. So we have a thing called an export, which has an identifying URI, and we say A, DRI export. A is just an abbreviation for an RDF type. And then that export has some members, and these members would be things within the archive, so they would be digital files described by URIs. Right, I've just realised what's happened here is I've actually opened the wrong... Let's try again. Sorry about this. I've opened an earlier version of the presentation. So I'm just going to open the correct one. Okay, so the Apache Jena framework provides a nice straightforward way of reading, writing and updating data using W3 standards. So for reading data we use the Sparkle 1.1 query language. For writing data we can just write out the new RDF and post it to the triple store using the Sparkle 1.1 graph store protocol. And updating and deleting is done using the Sparkle 1.1 update language. However, there is a problem with Sparkle generally in terms of people needing to learn the language, and there is a learning curve involved with Sparkle. Once you get used to it, it's okay, but TNA certainly would have some reluctance to spend a lot of time learning that language. So the answer that we came to was to use Elder, which is implementation of the linked data API, and that basically provides RESTful access to the Sparkle queries. So these are configured using a little bit of configuration, which is itself RDF. And here we have an example. So in this case, we have a URI template. So we're saying that whatever the underlying URI is, if we put collection on the end, then it runs a little Sparkle query. And this is the Sparkle query within the quotes here. So it's giving an item, which is a type of collection. So basically, if anyone goes to this URI, they'll get a list of anything that's in the triple store that's a collection. So no Sparkle needed, just a nice RESTful API. So how did we actually go about doing the work? How did we actually implement it? So the first thing we had to do was to create a mapping. Having created our vocabulary, we had to create a mapping from the relational database to the vocabulary terms that we created. And using that mapping, which itself was in RDF format, we were able to export the data from the relational database into N-quads, which is just another kind of triple, but it has the quads because they also have context. And those N-quads are then were loaded into the triple store, Jena TEB. However, the data wasn't quite how we wanted it, so we used Sparkle transformations, which are done using construct queries to refine the data. And you can basically, the way we did that was basically using Jena for Zeki. You can write your Sparkle construct queries. So this is the originating triple, not quite how we wanted it. It had this DRI collection UUID, which was something we came up with. Didn't really want to use that. We wanted to use doubling core terms, so we basically took the value from the collection UUID and put it into doubling core terms. And that enables you to just download it, you click get results, you get your RDF, and then you can load that into a clean instance of database. It's quite straightforward. So with Catalogue Services API, this is the layer that protects us. Okay, apparently I have 5 minutes left, I'm going to have to speed up a little bit. So we basically have very simple XML returned from that, as you can see here. Why XML, not JSON? Well, XML because the Catalogue services are consumed by other applications, and those applications are written in Java, so quite easy to get the data using JAXB and transform it however we want using the Java. Why not JSON? Well, in fact, we do use JSON in a few places where we have JavaScript within the application for things like tree editors and things like that, so we use JSON instead. So it's really about using the right format for the right place. Right, I'm just going to skip over this a little bit. This is the linked data API, which gives you some nice XML results. You've got a choice. This is the out-of-the-box XML format, which is the one that we actually use. So we just consume this in our application within the archive. This is the RDF format. Again, you just get this out of the box. You can have JSON, you can have Turtle format, whichever you like. Now there is a shortage of editors we found for working with Sparkle and RDF. This is one exception, which is Xturtle, which is an Eclipse plugin, which we found quite useful. Scala, we use Scala within DRI. This here is a bit of Java. The equivalent in Scala would be something like that, so much more concise. We're not using it at the moment, but it's something that we would do in the future, and if we were doing it again, we might do it that way this time. So will DRI Catalogue, will it cope with the tsunami? Well, we think it will, because it was chosen because it was performant. We're also confident we can scale it horizontally. We could create a catalogue for each collection that goes into the store. We don't have to keep expanding the same catalogue. So then you could have a catalogue of catalogues, which would search everything. If the existing framework fails to satisfy, then because we're using open standards, it will be relatively easy to, we hope, to switch to another format, to another underlying triple store. So what about the future? So far we've remodeled the catalogue and found a solution to problems of closure and export. But what next? Well, we can use some of that XML metadata that we already have. We can store some of that into the catalogue. But there's other things we can do as well. So this is discovery. This is the web front end. This is the sort of thing the public can see if you look somebody up. But as far as discovery is concerned, this is really just text. It doesn't know anything about these things. However, with a graph approach, and we can make this available to the front end, you actually have much more information. So you know that instead of just a string, a name is actually, in this case, we have a person. Well, we have this George Potter, who is an instance of a soldier. We also know that, well, we would know that a soldier is, well, it's a British soldier, we know that's a kind of soldier, we know that a soldier is a kind of person. And we have other information about this person. We have a rank, we have a unit, a regiment, and he won an award as well. So we know all these things. We can also extract information from text using natural language processing, and we can map that to RDF. So this is just a little snippet of text that came with that individual. We can use natural language processing to extract. These are terms that can be reasonably expected to be understood by. We could actually create an RDF vocabulary for this. So we've got places, we've got dates, we've got some terms like hospital, general hospital. We've got a Colonel Oram listed over there. Now at the moment, if you search for this chap, George Potter, in Discovery, you get 361 results, which is a bit of a shame, because actually 360 of them are irrelevant. There's only one that we're interested in. There's only one entry that applies to this person. But doing semantic search, which is something that would be enabled by the DRI catalogue, would allow you to say that you're actually searching for a person, or a soldier, or an officer with that name. This is something known as query string extension. Semantic search also allows for cross-referencing. Now you may remember there was mention of a Colonel Oram in that piece of text. Well, it so happens that we also have an entry for this Colonel Oram in the same system, so we could actually link these things together. And in linking this, we'd actually discover more information, because this is the award recommendation for Colonel Oram, which has quite a lot of information about it, which is actually relevant to the first individual that we were looking at. It describes the same situation. So we can gradually build up this graph of information about the assets that we have in the archive. So we can link things together, we can connect things, we can say that George Potter worked for, his unit was 49 General Hospital, as was Colonel Oram's. If I was able to browse this, I could see that they were connected in other ways. So for example, they're both in the Royal Army Medical Corps, they're both Army officers. There's all kinds of connections that could be made, all sorts of information that would otherwise be quite difficult to find. It also provides a way into linked data. So at the moment, all of this information is in the archive, and if we developed it further, it would still be in the archive, but we could open it to the wider world. We could unsilo the information and connect it to other organisations that are authorities on things that the archive's not an authority on. So, for example, things like the Ordnance Survey are obviously a more authoritative organisation on location information. British Library would have some overlapping information, and recently the Smithsonian Institute has started providing linked data. So there's lots of different organisations. DDP, of course, is the obvious one for the linked data world. These are things that could be linked to from the archive, either by people within TNA or by anyone else. We just need to make the data available. Another feature is that at the moment the Discovery actually allows members of the public to tag information, and this is just a sample of tags here. But these are they're quite individual. They're not necessarily things that other people look for. So some of this is actually a tag here where it says date of birth should be 12th of May 1925. So that's not necessarily a tag somebody else is going to look for. But if we were actually able to provide them with the vocabulary terms that we held in the archive, they could actually tag records with those vocabulary terms. So really the fundamental advantage of the graph approach is that it allows the open world assumption. So that basically, the open world assumption, as it says there, is implicitly assumed that a knowledge base may always be incomplete. So that's the beauty of it. If you want to add more information, you're not having to redesign your schema, you're not having to add new tables. It's quite straightforward to add information. And with something like an archive, where you really don't know what you're going to be putting into it, I would suggest that that's exactly the kind of approach that you want. And that's it. Thank you very much.
Thanks very much, Rob. Does anyone have any questions? Yes.
Yes, what exactly are you storing in the STB?
In STB, basically digital documents. So really any can be Word documents, Office documents, images.
You're not storing metadata?
And metadata, that's right. And I forgot to mention, there is a very good reason that we store XML metadata in the archive with the documents. And there's a very good reason for it being XML, which is simply that it's human readable. So if in 100 years' time people have forgotten what XML is, at least they can get a text editor, open the file and actually read it and see what's in there. And that won't change, it'll carry on storing.
So which schemas do you use for that, and how do you manage the change of schema definitions?
That's the next step for sure. We're not quite there yet. But yeah, and the intention is to take some of that XML metadata will continue to go into the archive, but we may extract some of that information and put it into our triple store as well, so that it can form part of that picture.
You mentioned the problem of many different formats, and the Doomsday book lasting only whatever it was 10 years or something.
Yeah.
How do you solve that problem of data being applicable to a particular application? A Word document of 15 years ago you can't read now. Do you update the data? Do you archive the software? I mean, how do you deal with that?
Yeah, that's a little bit beyond my kind of remit. My colleague Adam might have to say something about that.
So the way that we deal with it is we do format migration. So we don't preserve software, particularly, and we don't archive software. We do have a software archive just in case, but typically we have risk factors for file formats. And if we feel that they're becoming too risky, we'll obviously keep the original, but we'll migrate it to a more accessible format.
Yes, Julie.
You were talking about vocabularies. So is it ontology you were building, or is?
Yeah, a very small ontology. Really, we're trying not to do that. We're really trying to reuse existing vocabularies. So the XML metadata that we have in the archive at the moment uses a lot of Dublin core, for example.
Okay.
So we've tried to use that wherever possible. So the vocabulary that we've created is really very specific to the functions that we need to perform within the archive, for which we just couldn't find another way of talking about them.
Okay. Yeah.
One last question, anybody? Okay, thanks, Rob.